So we talked a little bit about regression output in chapter 1. And the book is very clear in terms of it doesn't ask you, we're not going to ask you to perform any of these kind of analyses, even in Excel or whatever the case may be, but being able to interpret what we are given. So we are given something like table 3-7 on page 93 of the text. And, we're given some information at the top, and it really doesn't matter, right? So we're given what are called, at the very top of it, so it's going to be rows 1 and row 12 in this table that we're given, because it corresponds to an Excel. In row 1, we're told the labels, right? So this is observation, this is quantity, and this is price. And then we're given the averages here. And so we're talking about, just a regular demand curve, right? And we're told that the average quantity is 450 for all of the different data points, right? So they've gone ahead and they figured out, at a certain price, this is how many hamburgers we're selling today at McDonald's, right? At a certain price, this is how many shakes we're selling today, so on and so forth, right? So just a regular demand curve. And so the average is 450. And the average price for this particular example is 455, not 465, 455. So these right here, and this is not anything that's going to be on the test because it's not a bolded term in the book, but just for your own edification, these are what's called non-parametric estimates. Or also you'll hear them called a lot of times called summary statistics. So summary statistics are just, your averages, your, counts. So that's the number of observations. Your standard deviations, those kind of thing, right? Those are all summary statistics. So those are we're just looking at the number by itself. Now, at the end of the day, what we're doing in these demand estimations, so what table 3-7, is showing the results for later on. So down below, it's got 32, 33, and 30, where 30 is just a row of labels here. And so this is talking about the intercept and then price. So what this is doing is this. So I'm not putting the numbers in here yet because I feel like it's just going to confuse us the more that we put the numbers on. So I want to give us the intuition first, right? So we have some sort of L, right? The first Cartesian coordinate plane, the positive and the positive, right? And we have elemento P, price over here, and quantity here. So this is what we normally have, right? But as we talked about before, the quantity is actually really a function of the price, right? It's not the other way around. When you go to the store, you look at the price, you decide whether or not you're going to buy it. When you look at an Uber or look at a pizza or something to buy, right? You're figuring out the price, if it's too expensive or not, and then you're going to buy it. So all of the quantity decisions for the companies are really made dependent on the price. They're a function of the price, which is why a price is one of the independent variables when we are running these regressions or getting this data-driven curve. So what we're actually doing is we're taking the quantity and we're putting it up here. So let's go ahead and rewrite this. So since the quantity really is the thing that we're estimating, and it's the price that's the independent thing, think about it. As the firms, we can control the price, right? We can decide today lattes are cheaper, or, yesterday tires are more expensive or something, right? So we can actually control the price. That's our independent variable. Our dependent variable is our quantity. So this quantity is some function of price. And so there are various data points that we're given, right? So I'm not going to go into the nitty gritty of it, but essentially, they've done some trial and error, and they've figured out, at different prices, they have different amounts of demand, right? And it's not always consistent, right? At this price, sometimes you get this amount of demand, sometimes you get this amount of demand, sometimes you get this amount of demand. But there's a general trend towards it in terms of as we get higher up, right, in the northwest, this is actually the northwest now, in the northwest section, right, they're clustered together. And then as we get lower in the southeast section, they're also clustered together, right? Because at the end of the day, there's a relationship here that we know, which is the law of demand relationship, right? So we know this is going to be a downward slope. So what the computer is doing, and this can be done by hand, and it's not fun. I had to do it many times in undergrad, not just grad school. I had to do a lot in undergrad for statistics class. You have to find what is the line in here. So is it that line? Is it this line? What is the line that, and here's the trick of it, not just the line that is the closest to all of these points, but it's the line that minimizes the squared distance from these points. So this distance here, this error or distance, we square that, and then we find which one has the closest squared distance. So why do we square it? Because there is a way to actually just not square it. Okay, so there's a different way of doing these things where you just look at the absolute value of the difference of the curve and the points, right? Just the difference, just how far it is, right? So this one is 1.5 squares, right? Compared to this one is only 1 square. This one is 2 squares, right? So there's a way to do this where we take the absolute value of those differences, and then we add those up together, and we figure out which one has the least amount of those absolute value differences. So that's one way of doing it. Why do we need to take the absolute value? Why couldn't we just, this is -2, this is -1.5, this is +1. Why do we need to take the absolute value of it? Why don't we just sum just the differences between the points on the curve? What would happen if we did that? So we have to go simpler. Okay. So these are my 3 points. And this is the curve. This is the line that I'm trying to draw to approximate the relationship that's happening between price and quantity, right? Does it make sense that I would draw the line here compared to drawing the line here, or drawing the line like this? No? It doesn't make sense to you guys why I'm drawing the line blue.
So from what you just said, I feel like you need to have an absolute value because it's like a price and goods, so it needs to be a positive number. Is that what you're trying to say? Because there is no like negative, like in an actual day-to-day scenario, like there is no way we are like paying negative amounts to.
Close. Very close. You're quite almost getting there. These are all positive values though, right? So this is all Q. That's in the positive realm here, right? This is all 1, 2, 3, 4, right? These, I'm literally just saying this is 1, 2, 3, 4. This is 1, 2, 3. Okay, so here we're gonna do an example, but I need to understand if you guys understand why we're drawing the blue curve, like where it's drawn, instead of the other points. Does this make sense that it's drawn here compared to over here?
I mean, it's way out of the axis, you know, so.
But it's not the axis that's important. It's the points. It's the data points that are important.
Oh.
These are the things that are important. These are the things that I've collected. That when the price is $2 or $3 or $2, that I sell 8 of these things. That's the important part. Okay, it's the data points. So when the price is $4, $5, $6, I'm selling 9. And when the price is $8, I'm selling 2. So does it make sense why I'm putting the curve where I'm putting the curve compared to putting it out here, or compared to drawing it like this, or drawing it like that, or drawing it like this? Does it make sense why I'm drawing it the way I'm drawing it? Not everybody's shaking their head. Why doesn't it make sense?
I'm just trying to figure out if the line is there because the quantity is going down.
Yes. Yeah. Yeah.
Okay.
Yes.
Okay.
Yeah. So it's and it's just in between the points. It's just in the mix. So same like there are all these points over here, and it's just like in the mix.
Okay. Well,
Compared to if I were to draw a line over, if I were like, oh, the thing that fits this best is over here, right? That doesn't make any sense. It's nowhere near any of the points, right? I'm trying to get it in the middle of the points. I'm trying to have it be representative of the data points, of what's going on there. Okay, cool. So if we just were to take the difference of, so this line is a prediction. This line is an equation that's telling me that at $2, I'm predicting that you're going to sell 10 of those things, right? But you actually only sold 8. So the difference between the line and how many you sold is what? 2. Now what about here? The line predicted that at $6 you would sell 7, but you actually sold 9. So what's the difference here? 9 is 2, exactly. Very good. That's the point I was looking for. So now, if we were to just add up, let's just ignore that this point even exists for the moment, okay? If we were to just add up the differences, 2 plus minus 2 ends up being 0. 0 is telling me that there's 0 errors in my curve, right? It's telling me that my curve is telling me exactly the quantity that I am going to be selling when I know the price. But that's not actually what's happening, right? What's actually happening is that it's 2 give or take. So because of the fact that some of the errors are negative and some of them are positive, that's why we have to take the absolute. So there's 2 ways to do it. One of the ways is you take the absolute value of all of them. The other way is you square them. Now the nice thing about squaring is that, let's say there's a point that's really close. Right? If it's a point that's really close, like right here, that's, 0.25, right? So by squaring that, it rewards it. It becomes 0.125. Maybe. I don't know. It becomes smaller. So, 0.5 becomes 0.25, right? So 0.5, we square it, and it becomes 0.25. So it's rewarding those points that are close to the curve in terms of less than 1. And then anything that's greater than 2, right? 2 squared is 4. What if it's, this one right here, this green one that I said to ignore, right? That's 3.25 away. We square that becomes, over 9. Right? So it punishes those points that are further away. So there's 2 main ways to do this. We can literally just look at what's the absolute value difference, or we can look at what's the squared difference. So the book and everything is always going to use the squared difference. So that's the intuition behind what's happening. Is it's drawing a million lines, and it's taking the square of all of the different individual errors. It's like, okay, this one, it predicted 10 and it said 9. All right, so 10 minus 9 is 1, 1 squared is 1, and then we add that. And it takes the one that has the least amount of errors. So the one that's closest to 0. So none of them are going to be 0. They're all going to have some kind of error, but the one that's closest to 0 is going to be the important thing. All right, so we're given, in the text, we're told the intercept is 1,631.47. And we're told the price is negative 2.60. So let's just go over what these things are. So these are what's called the coefficients. And so the book writes this in equation form right above it on page 93, and it says that these values are corresponding to, the standard kind of y equals mx plus b, right? In terms of where the b is the intercept, and the m is the slope. Now, why is the m? Why isn't it called slope? Why is it why is it price instead of slope? Why does it say coefficient on price instead of slope?
Because the price is the one that representing the slope here.
Because the price is the one that's representing the x here. Yeah, very good. So the price, instead of saying m, right? This over here is the x. So this, and the y, that y is just whatever is the thing that we're doing the regression on. And so we're always told that, there was a regression, there's a regression on something. They're estimating. So it's whatever we're estimating. And so it's going to be quantity is equal to negative 2.6 times price plus 1,631.47. So this is how we interpret these kind of things. This is how we pull the information out of there. Don't worry about, have you guys taken any stats? You taken stats? Have you taken stats? No stats? Have you taken stats? No stats? BMO? Yeah? All right, so let's not worry about standard error, t-statistics, or p-values. That's 3 whole classes. All right, it's not always just going to be one variable, though. That's why these things are kind of difficult, because not only is there price that's influencing my decision. So let's get a new thing here. So if we go to table 3.8 on page 95, this one has multiple things that it's using to estimate the quantity, right? And so this, and of course I can only draw in 3 dimensions because I'm not a wizard, but this looks like this. So let's just do price and advertising, okay? So this is the price axis. This, which would normally be the z-axis, right, which is showing depth of the cube, right? So now we're going 3 dimensions, so it's like a wooden block. This is the advertising axis, and then this is the quantity demanded. And so now all of these different data points that we have, they now have 3 dimensions to them, right? So now this is saying that when my advertising is at, $1, $2, $3, $4 million, when my price is at $1, $2, $3, $4, $5, then my quantity demanded is going to be 1, 2, 3, 4, 5, 6, 7. So now instead of just being an XY pair, now it's it's an XYZ pair. So instead of just being price, it's price, advertising, quantity demanded. And there's more dimensions than this, but we can't conceive of them.
Is there a way to put this to an equation or not?
Yeah, absolutely. That's exactly what we're doing. So in table 3.8, that's what we're doing. Is there's a point that's going through. It's skewering this. You can kind of think of this as like a loaf of bread or something, right? Loaf of bread. I can't draw, but it's 3-dimensional, and you're skewering it. You're trying to find the skewer that minimizes the distance between all 3 of the different variables. So all 3 of the different things, right? So it's the same thing as what we did before. Now we're just adding an extra layer. So now instead of just being a flat sheet of paper, now it's a book. Now it's a loaf of bread instead of a slice of bread. And so absolutely. So we'll be able to find a line that best approximates what's going on with these 3, and we're given the line in a very similar way. So we're told coefficient. We're told the intercept. We're told the price coefficient. And then we're told the advertising coefficient. And so how would we put this into equation form? So using that same process that we did before with the single variable, let's go ahead and give it our best shot. Put together the formula now with 2 variables. So not all 3. The book actually talks about all 3, but no need to get ahead of ourselves.
You want it in Y form, right? Not Q.
Q, in Q, yeah. Because that's what we're estimating, The Y is mx plus b. I'm just doing that for to tie it to exactly, yeah. Yeah, we don't usually mix those. It's always price and quantity, price and quantity. Close?
I don't know what to do.
You don't know what to do with that? Try it. This is called synthesis. So analysis and then synthesis is you go one step further. So what did you do with the last one? Do the same thing with the advertising. Yep, so that's right. But now there's more than one factor that's influencing quantity, right? So it's just another term in that quantity equation.
Oh, okay.
That's a sound I want to hear.
Oh.
Yep, close. And then how do we integrate that last one? So do the same thing for that advertising variable. So it's just another term in that quantity equation. So you're close. So you're missing your price, right? It just says 0.4, 0.1. You could just evaluate that, right? Negative 0.14 plus 135.15. That's 135.01. No, I mean, so you got to multiply this by price, right? This has to be multiplied by something. This is the M. It's got to be multiplied by an X. This is the B. This is the intercept. This is the price. Right? So when we had it over here, we put it down here. You didn't put the price. You just said negative 2.6 plus 106, right? You just added. So you need to multiply it by something. Multiply it by the price. Very close?
So right, because that's the line. So put it
So,
there.
but it's not X.
No, it's a times.
Times. Oh, so you have that times that.
Right?
But so that would be. So what you did right now would be if I said evaluate the predicted quantity when the price is equal to 0.54. This is telling me the relationship that the price has to the quantity. That's what this negative 0.14 is telling me.
Okay.
It's telling me that as the price increases, my quantity decreases by 0.14.
Okay.
So by multiplying it by 0.54, you're saying you're evaluating this quantity when the price is 0.54.
Yeah.
But what I want you to do is keep this 0.14 times price, which is what I thought that was.
Yeah.
Just keep this negative 0.14 times price. Keep this plus 135.15, and now add a new term that's talking about the advertising and the slope or the coefficient on the advertising. Nope. So a whole new term, whole separate term. So this is completely correct. Just add a new term that's like this term. Shouldn't even multiply. Okay. We are running out of time. Okay, so how did we do it before over here, right? We took the intercept, and that was our B, and our mx plus b. Now we literally, instead of y equals mx plus b, now we have y equals mx plus nz plus b, okay? Where this n is the other coefficient, so the advertising coefficient, and then the advertising is the z. So literally it's just, and it's not y, it's just q equals negative 0.14 times price plus positive 0.54 times advertising plus 135.15. So it's just a whole separate term. So we don't multiply it by anything. We don't. They're just there. So the other way we could write it, Q equals 135.15 minus 0.14p plus 0.54a. All right, so let's do one question at least in the last couple minutes of class here. So, all right. So, Indifference curves and budget lines. Number 1. We're told that a consumer has $300 to spend on goods X and Y. The market price of these two goods, PX, is equal to $15, and PY is equal to $5. What is the market rate of substitution between goods X and Y? So the market rate of substitution between any goods, as we know from our reading, is just the difference between the price of good X and the price of good Y. Oh, sorry, it's the negative of it, because it's always downward sloping because of just the nature of budget lines. It's the nature of scarcity, honestly. I'm going to give up something for another thing. Something I've been having to teach over and over and over again to my 3.5-year-old. The nature of scarcity. Very patience enhancing. So this is going to be negative 15 over 5, which gives us negative 3. So market rate of substitution is negative 3 here. So we're asked to illustrate the consumer's opportunity set in a carefully labeled diagram. So let's go ahead and do that together in the last couple minutes that we have. Oh, actually, it's not price and quantity this time, because now we have goods X and goods Y. Oh, and let's put them on the corresponding axes, because that'll make everything a little bit easier. And so, this is question 1 from the back of the book, page 130. So this is one of the questions from the end of the chapter. So number 1. So if we have $300, what's the maximum amount of Y that we can buy? Uchi, what's the maximum amount of Y we can buy? $50? How'd you get 50? Did you say 50?
No.
What'd you?
I thought
15. 15 is the price of X. So if you have $300 and everything's $5, how many can you get? Please don't say it out loud. So if you have $300 and each one of them costs $5, then the maximum amount of Y that you can get is going to be 300 divided by 5, which gives me 60 units of Y. If I have $300 and I just buy X, then that's going to be 20X. And so then we connect these and we get our budget line, and this whole region is our opportunity set. So what happens if our income increases to $600? What would happen to this curve? Bimo? Very good. The budget line will go upward, will go over and to the right. So it would take a shift, because now instead of 300 divided by 5, I have 600 divided by 5, right? I have 120 as my maximum amount of y that I can have. And instead of 20, I have 600 divided by 15. So now I have 40 in terms of my maximum amount of x. So my new budget line is right there as a result of the increase in the income. All right, everybody. So you got the reading for next week, or sorry, for Wednesday, not next week. So the reading for Wednesday, again, is, to write it down because 114.
Yeah.
To 122. All right, so 8 pages. Please read it. I'll have some simple Kahoot questions at the beginning of class to get attendance. And like I said, I'll be updating the grade book so that the attendance will be per day, right? So, and I'll probably, I'll just have it add 5 points every day. And I'll load it right after class when I upload these videos. And we'll have an in-person test in a week.